vectors in 3 dimensions. Directional cosines. So we use directional cosines to work out the angle a vector makes with either the x-axis or the y-axis or the z-axis. And there are some formulae, which are these. These are called the directional cosines. So you've got some vector with components x, y and z. So if you want to know the angle this vector is making with the x-axis, so we're looking at this formula, you need the x value here divided by, and this is just the magnitude of this vector. Yeah, these are easy to work out. And when you divide them like this fraction is the cosine ratio of some angle. So if you do cos inverse of this fraction, this cosine ratio, you'll get the angle that the vector makes with the x-axis. You can do the same thing with the y-axis. There it is, you've got the y component, so now it's y divided by the magnitude of the vector. So if you do cos inverse of this, you'll get theta y. And then you've got the same with the z-axis. You've got the directional cosine here. You've got the z component from here, again divided by the magnitude, so this is the cosine ratio, and cos inverse of that will give you the angle theta z. You don't need to know the proof for these directional cosines for the purpose of the exam. You just need to be aware of how to work out an angle with a particular axis. Angle with the x-axis, the angle the vector makes with the y-axis, and again with the z-axis. So let's start with this example. We've got a point with coordinates x, y, z, and here's a vector that takes us from the origin to this point, so that's a position vector, vector A. And then vector A can be written as x, y, z in column vector form, and its magnitude is this, using 3-dimensional Pythagoras' theorem. And the angle the vector makes with the x-axis is here. And if I make a right angle triangle, all I need now is the length of 2 sides, and you can use some trigonometry to work out the angle. Now we know that the length of the vector is its magnitude. That was from Pythagoras' theorem, x squared plus y squared plus z squared, and then you square root that. And along the x-axis, this value here, or the length of this line, is just the x component here. So then cos theta is the adjacent divided by the hypotenuse, like this. And I'm going to replace the magnitude of the vector with this, which now gives us this formula. And this is one of those directional cosines. So in a similar way, the angle the vector makes with the y-axis is given from this right angle triangle, and we know the length of the hypotenuse and the adjacent, so using the cosine ratio here we can easily work out the angle. And then we can do the same again with the angle the vector makes with the z-axis this time. So this length here in this right angle triangle is the z component. Again, we know the length of the hypotenuse, so in the right angle triangle you've got the adjacent, you've got the hypotenuse, so the cosine ratio. And a quick summary of the cosine ratios, and if you do cos inverse to any of these ratios, we get these angles. So the angle with the x-axis, y-axis and z-axis. Okay, so in this example we're given a vector in component ijk form and its column vector form, and to work out the magnitude we're just going to use Pythagoras' theorem in 3 dimensions, so we get this. So we've got the 2, the -3 and the -1. Those components are here, you square them all, you add, you square root, simplify, you get root 14. Okay, so I've got my vector and its magnitude. So part B, the angle the vector makes with the x-axis. So cos theta is equal to the x component here divided by the magnitude of the vector, root 14, and that will give me the angle it makes with the x-axis. So the angle with the x-axis, if you do cos inverse of this ratio, 57.7 degrees. And now the angle with the y-axis, so we want the y component, -3, over the magnitude of the vector, root 14, again cos inverse of this ratio, we've got the angle. And then finally with the z-axis, the z component is -1, magnitude of the vector, so theta z, the angle with the z-axis, 105.5 degrees. For further practice, try these questions.